Okay, so this is Unit 4, Objective 9, homework help. So I'm going to start with question number 1. So I have to solve algebraically. So I'm going to isolate the radical as step 1. So the radical is already by itself, no numbers outside of it. So then I'm going to square both sides. So then the square root of x plus 1 squared is just x plus 1. And then here to square this, I need to write it twice and then distribute. So all I'm doing is distributing the x into both terms and then the negative 1 into both terms. And then combine like terms. So negative 1x and negative 1x is negative 2x. And then I want to set it equal to 0. So I'm going to subtract x and the 1. And I want to make sure I line it up with the like terms, so the x's with the constants. So negative x and negative 1 will cancel that to 0. And then I have x squared. And then negative 2 and negative 1 is negative 3x. And then 1 minus 1 is just 0. And then because I have a quadratic, I want to factor it. So this is just a common factor. So I can factor out the x. And that leaves me with x minus 3. Set each factor equal to 0. And then solve. So I can add 3 over. And then because I solved by factoring, I want to check for extraneous roots. So if I were to replace 0 into here, 0 minus 1 is negative 1, and a root can't equal a negative, so this one is extraneous. If I replace x with 3, 3 minus 1 is positive 2, and the square root of 3 plus 1 is also 2. So then, now for graphing, so it says now to accurately graph the system of equations, which is from the algebraic equation in part A. So this is just the left side of the equation and then the right side of the equation. So then for here, I know that this is shifted left 1, so left 1. And then I'm just going to do mental math here. So when I replace x with a 0, I get 0 plus 1 and then the square root of 1. I also know the square root of 4. So because I know the square root of 4, that was when x is 3, right? Because 3 plus 1 is 4. So x is 3, 1, 2, 3. And then the square root of 4 is 2. So for this one right here, I'm going to add 1 over because this is not grouped, right? So it's not with the x. So that would be y plus 1 equals x. So then my shift, I'm going nowhere left or right, but in this case I'm going to go down 1. So I'm going to go down 1, and it's a slope of 1, so that means I'm going to go up 1 over 1, and then I'm going to do that a couple more times just for accuracy. So then it's a straight line. Okay, and so where they intersect is right here, which is at 1, 2, 3, 2, so at x equals 3. And so that's the one that we got over here, right? We got 3 and not the extraneous root. And so the extraneous root would come about, remember, so this is just the positive half of this quadratic, right? When we square it out, we create a quadratic, which is a parabola. So this equation, if I were to graph it, right, it's, you know, off of the x instead of the y, but it would look like this, and that's where this x equals 0 extraneous root is coming from. So if I'm just going to dot this, right? So that quadratic, now I get that it's, you know, the orientation is not quite right, but that's where that extraneous root is coming from. Okay? All right, and then let's take a look at number 3 here. Graph that one. So solving for x. So I'm going to go ahead and square both sides because there's nothing around the radical to get rid of. So that would be just x plus 3. And then 2x times 2x is 4x squared. And so now I want to go ahead and set it equal to 0. And I want my x squared term to stay positive, so I'm going to subtract the x and the 3 over. So that would just be 0. And then nothing combined, so I'm just going to write everything side by side. And so now I have to factor this. So I know for 4x squared it could be like 4 and 4 or 2 and 2. So I'm going to try 4x and 1x first. And the reason I did that was because I know I needed to get a 1 here, and the 4 and the 3 just seem closer together. So then the 3 here and the 1 here. And so then it needs to be negative 4x and positive 3. So if the factoring part is giving you trouble, you can do it a little bit slower if you want to, but in general, we're just doing guess and check, right? So I'm a little bit quicker at these because I've been doing them forever, but this would be 4x squared, and then negative 4x plus 3x, and then negative 3. So then set each factor equal to 0. So subtract 3, and then divide by 4. And then x minus 1 equal to 0, and then add 1. So then if I look here, if I plug 1 in, so 2 times 1 is 2, so that could equal a positive, right? Or that's a positive 2. And if I plug 1 in, so square root of 4 is 2. So that one's good. So negative 3/4 times 2, doesn't matter what that number is other than it's negative, and a root can't equal a negative, so I know that's my extraneous solution there. Okay. So now we're going to rewrite and graph. So I'm going to rewrite that. So that would be y equals the square root of x plus 3. So I'm shifted left 3. So 1, 2, 3. And then if I plug in negative 2, right, I'll get square root of 1, which is 1. And when x is 1, that will give me 4, right? And I know the square root of 4. So when x is 1, the square root of 4 is 2. And I'm going to graph that. And then my other equation, so y2 is this side, so 2x. So I have no shifting, right? So I'm not adding or subtracting anything, so it goes off of the origin. But then my slope is 2, so I'm going to go up 2 over 1. So up 2 over 1, up 2 over 1, and then graph a straight line. And so then they intersect at x equals 1, which is good, right? Because that's what I got for my value here. Okay. And then again, if I were to do my reflected part of the quadratic, which is what I generated from here, right? Again, the orientation is off, but just in general. And then that's where I'm getting the extraneous solution. Okay? All right, and then let's take a look at the back side. Okay. So let's start with number 5. So I want to solve, so I want to isolate the radical. So I'm going to add 2 first, right? So any number outside of the radical, I need to move first. So 2 plus 2 is 4. And then to get rid of the 1/3, I'm still trying to get rid of the radical, I'm going to multiply by 3. So 3 over 1. So that cancels to 1. And then 4 times 3 is 12. And then I'm going to square. So x plus 5 equals 144. And then subtract 5. And I didn't have to solve by factoring, so I don't need to check for extraneous solutions. Okay. And then let's take a look at number 11. So I can't isolate a single radical at this point, right? Because I have a radical on both sides. So I'm just going to square both sides. So then that cancels to 10x plus 8. Here I have to square the 2, so 2 times 2. And then root 3x times itself is just 3x. And it's grouped now, right? So multiply the 4 and the 3x together. So So that would be 12x. And then now I just want to do simple solving, right? I'm not solving by factoring because I don't have any squared terms. So I'm going to subtract the 10x over. And then divide by 2. Okay, and then let's take a look at number, how about number 17? So I want to isolate the radical. So I'm going to subtract the 3x over. And then I'm going to divide by -5. And then when I look at that, I say, that's going to be not a very fun problem, is it? Okay, so root x equals, and then that's 2 minus 3x over -5. Then I'm going to square both sides. So that is just x. And then distribute this out. So I'm going to do that in my head. So that's 2 times 2. And then -6x twice. And then 9x squared over 25. -5 times -5. Okay, I need more room. I'm going to get rid of my fraction, so I'm going to multiply both sides by 25. So that'll be 25x. And then I'm going to put my 9x squared term first. -6 and -6. And then +4. Okay, so I have a quadratic, so that means I want to set it equal to 0. So I'm going to subtract the 25x over. And then I want to factor this. I'm going to slide this up. So then I'm going to, so 9x squared is 9x times x, and 4 could either be 4 and 1 or 2 and 2. And I went for the 4 and 1 because that gives me 36 and 1, which is 37. And then set each factor equal to 0. So I'm going to add 1 over, and then divide by 9. So it will stay 1 over 9, right? And then here I'm going to add 4 over, so x equals 4. Okay, and then let's go back to, so I had to solve by factoring, so one of these is going to be extraneous, so I guess let's just go to the beginning to check it. So that was my original. I'm just rewriting it so I have it kind of handy. Okay, so I'm going to do 4 first just because it's an easier number to work with. So I'm going to replace x with 4. So then 3 times 4. And I want to know, does that equal 2? So 3 times 4 is 12. Replace x with 4. And so I'm hoping it's equaling to positive 2, right? I don't know that. So that would be 12 minus, and then 5 times 2 is 10. And does 12 minus 10 equal 2? It does. So this is good. And so now for 1/9, so now I'm going to substitute x as 1/9. So that's going to be 3, and then 1 over 9 minus 5, and then the square root of 1 over 9. So this would be 3 over 9, which is 1/3. Minus, and then this would be 1/3 as well, right? Because the square root of 1 is 1, the square root of 9 is 3. And I want to know, does that equal positive 2? So this is 1/3 minus 5/3, which is 1 minus 5 is -4 over 3, which is definitely not 2. So then 1 over 9 is my extraneous. Okay? All right, and that's it.